Let's start with that first example of the DC analysis of MOSFET, and we have this circuit, 10 volt, our transistor, NMOS, enhancement NMOS. This is of course the drain, this is the source, this is the gate, and then we have 4 resistors connected in this shape. Of course, we can just simplify the plot of the circuit by plotting it in a different way. So we can, this 10 volt is connected to this branch and to this branch, so we can just separate these 2 branches to make it easy. So we can plot the circuit like this. We can say that we have 10 volt here, connected to RD, then our transistor, then RS, and then we have here also, we have 10 volt here, which was the same 10 volt, but we separated it to make it easy to see. And we have here 2 resistors, R2 and R1. And we have the values of all the resistors available. Okay? So, the first thing to notice, this is the drain source, is that IG equals 0, which means that the current in resistor R2 and the current in resistor R1, they are the same, right? So if we have here current called I, the current here also will be I. Since the current is the same, we can calculate the voltage of the gate using voltage divider. We can say that the voltage here, the voltage at this point, let's call it VG, okay, can be calculated as 10 volt multiplied by this resistor over the sum, right? So VG equals 10 multiplied by R1 over R1 plus R2. R1 is given as 1 and R2 is 1.5, so it will be 10 multiplied by 1 over 2.5. This will give you 4 volt. So now we know that the voltage of the gate here, we know that the voltage of the gate, the voltage of this point is 4 volt, right? Now, let's assume that the current here is called ITS. This is the current of our transistor. And since we don't know whether the transistor will be saturation or triode, we'll assume, as we said, assume saturation. We'll start always with assuming saturation. And then we consider this loop, the gate source loop. We have a voltage here between the gate and source, it's called VGS. So we can say that the voltage of the gate, which is 4 volt, this volt, equals what? Equals the drop across the resistance plus VGS equals the gate volt. So the voltage of the gate equals VGS plus the drop across this resistor, which is ITS RS, right? The voltage of the gate we already calculated to be 4 volt. So this 4 volt comes from the drop here plus the drop here. VGS plus IDS RS. But we know that IDS already depends on VGS, right? So we can say that VG equals 4 equals VGS plus IDS. IDS can be written as Kn over 2 VGS minus V threshold squared. So now, by replacing IDS in terms of VGS, we have an equation in VGS. It's a quadratic equation in VGS. So you expect that you will get 2 solutions. By the way, we were given that the V threshold equals 1 volt and Kn, the constant Kn, is 25 microampere per volt squared. And this is the units of Kn, microampere per volt squared, because Kn is multiplied by a volt squared and it gives you current. So it must be ampere over volt squared, or milliampere over volt squared, or microampere over volt squared. Anyways, so we replaced IDS with this equation, and since nothing was mentioned about lambda, about the channel length modulation, we assume that there is no channel length modulation. So the equation of the current in the saturation would be only this. Now we have a quadratic equation. We can just substitute about RS. RS was 39 kilo. And Kn, since we are dealing with kilo, we can convert Kn into milli. So Kn can be written as 0.025 milli over 2 VGS minus 1 squared. Why did I convert Kn to milli? Because when you deal with kilo ohm and milli, this will result in volt. So here you have volt, then you deal with kilo ohm and milli, or ohm and ampere. So kilo ohm and milliampere, or ohm and ampere, right? So I converted the Kn into milliampere so that when we multiply by the kilo ohm, it will give us volt. Now we have a quadratic equation. If you expand this quadratic equation, you will find that you can write it as 0 equals VGS squared plus 0.05 VGS minus 7.21. Of course, you can solve this quadratic equation to find its roots, and you will find that you have two roots. VGS equals negative 2.71 or VGS equals 2.66 volt. When you look at these two roots, you will find that one of them is valid and the other one is not valid. For example, the transistor cannot be saturation while VGS is negative, right? VGS here, this VGS is less than V threshold. So this solution is not valid because we assume saturation. If we assume saturation, VGS cannot be less than V threshold, right? So this solution, we say that this solution is not valid or invalid, right? Why again? Because we assume saturation, but VGS turned out to be less than V threshold, which means that the transistor is cut off. So this solution is invalid. And this is the one that is valid. So we will continue with this one. We will continue with the valid solution. We calculated VGS. So we can go to the current equation and we substitute with this VGS to calculate the current. The current equation says IDS equals Kn over 2 VGS minus V threshold squared. So now Kn is 25 micro ampere per volt squared over 2. VGS we already calculated minus V threshold given as 1. So you can calculate the value of the current and you'll find that the value of the current is 34.4 microampere. So now we calculated VGS, we calculated the current. Now we can go to the other loop. The drain source loop. So we'll say consider the drain source loop and we'll apply KVL. When we apply KVL, this 10 volt equals what? 10 volt equals the drop across this resistor plus VGS plus the drop across this resistor, right? So we can write KVL in the drain source loop. KVL in the drain source loop says that 10 volt equals VGS plus the current IDS multiplied by the resistance RD plus the resistance RS. We already have the current, we have the resistance RD and RS, 75 kilo ohm and 39 kilo ohm. So what we can do is we can calculate from here, we can calculate VGS to be 6.08 volt. Now it's time to check. We assume saturation and we obtained VGS, we obtained IDS, we obtained from the drain source loop, we obtained VGS. It's time to check. Let's check. How do we check for saturation? We need to check whether VGS is greater than VGS minus V threshold or not. VGS minus V threshold equals VGS is 2.66 minus V threshold, which is 1. It will be 1.66 volt. And VGS is 6. So VGS is greater than VGS minus V threshold. Then we say that our assumption of saturation is correct. So assumption is correct. And that's it. We finished now the first example. We'll see you in the next video with another example.